Hi all, welcome back to a new video. In this video, we're going to solve an astronomy problem by the name of Whenwolves. So in this problem, there is a planet which has a surface gravity 3 times of Earth's with the same radius. Its moon's circular orbit has a radius 90 times of the planet's, and for reference, we know that the moon's is 100 times of 8 times of the Earth's and has an orbital period of 27 days and 8 hours. On this planet, wolf-like creatures appear every full moon and attack. Every 12-hour day, its star's ascension recta increases 2 minutes. If last night was a full moon, how much time do they have to prepare themselves? Okay, see that this is quite a long question, but we can take it step by step. So, what do we know here? We know that the gravity on its surface is 3 times of Earth's and has the same radius. Now, what can that actually do for us? Well, we can modify the Newton's law of universal gravitation, which is gm over r squared. We put m as 4 pi over 3 r cubic times rho because planets are spherical. If we cancel out the r's and we switch it around to find rho or the density, which is 3g over 4 pi gr. So we know that its gravity is 3 times of Earth's and its radius is the same. So we know that the density of the planet is equal to 3 times the density of Earth. Now, why does that matter? Well, we'll see in the next slide. Next step, we're going to modify Kepler's third law, which is gm over 4 pi squared is equal to a cubic over p squared. We expand the expression for mass, which is 4 pi r cubic rho over 3, and we switch around the terms to get the period squared is equal to the distance from the two objects divided by the radius of the planet cubic multiplied by the density of the planet multiplied by 3 pi over g, and we just have to find the square root of it to find its period. Now we have to compare that period with the period of the moon because for reference, because well, that's the one that we know, and we find that the period of the other planet's moon is 1493.607 hours. So that is why in the beginning we were given the a over r, or the distance from the two objects divided by the radius of the planet. Alright, now we know that the moon of the planet revolves around it every 1493.607 hours. Well, what does that do for us? Well, we know that that's the sidereal period, and every full moon happens every synodial period. How do you find that? Alright, so first we must assume that the planet's orbit is circular. So 1 times orbit, it means that the ascension recta of the star comes back to where it began. So it's because it changes 2 minutes every 12-hour day, so it'll need to do that 360 times over, or we can say that the planet rotates around its star for 360 days. Alright, so we'll know that 1 over the synodial period is equal to 1 over the sidereal period of the moon circulating around the planet, subtracted by 1 over the sidereal period of the planet circulating around the sun. If we were to do the algebra here, we will find that the synodial period is equal to the period of the planet around the sun multiplied by the period of the moon around the planet divided by the period of the planet around the sun subtracted by the period of the moon around the planet. And if we were to use all the terms that we have found before, we will find that the scientists have 95 days, 3 hours, 49 minutes, and 20 seconds from the last full moon. Now, obviously, that we know that it's not as much as that. It's probably like a few hours less than that, but we get a rough estimate of around 95 days. So thank you for watching this video. Hope you enjoyed and you learned something new. Thank you.